Hello, in this problem we have two logarithms and the question is to write it as a single logarithm whose coefficient is 1. So the idea is to use something called the product rule. The product rule says if you have the log base b of x plus the log base b of y, that this is equal to the log base b of x times y. So the addition turns into multiplication. You'll notice, though, that in our formula, there's no numbers in front of the logs, right? So here we have numbers. So in this problem, the first step is to get rid of these numbers. And it's not so hard. Uh, an easy way to think about it is to first remember that there are implied parentheses here. And then remember that whenever you have a number in front of a log, like this one, you can just make it the exponent. Boom. So take this one and make it the exponent. Boom. Let's do it. So this is log base 5 of 5m squared. And now it's the exponent. So this is negative 2 over 3 plus, plus log base 5 of 25, and then m squared. And this is to the now 1/2, right? Because we're taking this one and putting it up there. Before we use the product rule, let's go ahead and simplify this a bit. This is log base 5. So how this works is when you have 5 times m squared and you're raising it to the negative 2/3, you basically raise each piece to the negative 2/3. The rule says if you have, say, ab to the n, this is just a to the n, b to the n. So we'll have 5 to the negative 2/3. And then we'll have m squared to the negative 2/3. So we're going to have this, m squared to the negative 2/3. That's what we're going to have. Except when you do that, there's another property that basically says that when you have a variable to a power, you just multiply them, okay? So you can just look at this and say, okay, I'm going to multiply the negative 2/3 times the 2. So that's going to give us negative 4/3. So m to the negative 4/3. And I'm going to go ahead and put this in parentheses again, just for clarity. It just looks easier to me when it's in parentheses. Plus, but you don't have to do that. You can leave the parentheses out. Same thing here. We raise each piece to the 1/2. 25 to the 1/2 is just 5, right? Because it's really the square root. Remember, the 1/2 power is the same thing as the square root. So the square root of 25 is 5. And then m squared to the 1/2 is just m. By the way, I didn't say it, but we're assuming everything here is positive, so all variables are positive, right? Okay, so now we can combine these even further, right, by using our product rule, which was up here, right, this one, right? So because we have a single log plus a single log, there's no numbers in front anymore, right? We got rid of those numbers. So you basically just multiply each piece, right? X times y. So it'll be log base 5 of, the first piece, so 5 to the negative 2/3, m to the negative 4/3, times, and then 5m. Okay, so that's your x, that's your y, you see? X, y, and up here it's x, y, x, y. So you're just multiplying them. All right, this is going to be fun. Log base 5, harder problems. When you multiply these, like the 5 to the negative 2/3 and the 5, there's really a 1 here, okay? And so you add the exponents. So I'll do it over here so you see it. 5 to the negative 2/3 times 5 to the 1. That's really 5 to the negative 2/3 plus 1. 1 is really 3/3, so this is just 1/3, right? Think of it as 3/3. 3/3 plus negative 2/3 is 1/3. So this is 5 to the 1/3. Okay. And then same thing here. We have m to the negative 4/3 times m to the 1. Think of 1 as 3/3. When you add 3/3 plus negative 4/3 is negative 1/3. Ridiculous. So that would be an acceptable final answer. You could probably keep writing it and write it as a cube root and stuff and bring this downstairs, but let's stop here. I hope this video has been helpful.